Hello juniors, today we're going to see the third and last part of this electronic assignment number 4, Venn diagrams. To make a quick review, we saw the basic definitions of the properties and the elements of a Venn diagram. We've seen what a complementary event is about, and we've also seen the concept of intersection of events, right? Whatever two or more events have in common would be the intersection. Then we saw union of events, the U, right? Remember the clue words we have seen for the intersection, the clue word is and or also but. And for union, the symbol is U and the clue word would be or, right? We've seen some examples. Then we saw the addition rule, which is combined events. We saw the formula, which is available in the formula booklet. And then we've seen some exercises about this. Okay. So for today, what I want to do is see the last part, which is mutually exclusive events. And you see that this is also an easy concept, and we're going to do an example about this, and then that'll be it for this video. So what is mutually exclusive events? It says, in a student survey, it is found that 32 students play chess. Chess and archery clubs are on the same day at the same time, so a student cannot do both archery and chess. So there's no way a student could do archery and chess because the classes are at the same time, right? Same day and same time. So in this type of cases, we talk about mutually exclusive events. It says the events A and C are called mutually exclusive events. These are events where two outcomes cannot occur at the same time. Here we can see that the circles do not overlap. That means that the intersection between them is always 0 when we talk about mutually exclusive events. So the probability for the intersection would also be 0, right? So if we go back to our formula, if you remember the formula for combined events, which is this one over here, you will see that for mutually exclusive events, this element gets eliminated, right? Because the intersection between A and B is always 0 when we talk about mutually exclusive events. So if we want to find the union between both events, it's just probability of A plus probability of B. Okay, that's the whole new thing about this part, right? So it says, generally, if two events A and B are mutually exclusive, then it follows that the probability of the intersection is 0. Hence, we can adapt the addition rule in these cases, and we can say that the probability of A union B, or A or B, is the probability of A plus the probability of B, right? You can see that in the graph as well. If I want to find the union, remember the union implies painting all of the circles. So this circle and this circle. So the union would be 38 plus 32 directly, right? And as there's no intersection, we do not subtract any other number. Okay. So here it says, in general, if A and B are mutually exclusive, then the probability of the intersection is 0, and the probability of the union would be a probability of A plus probability of B. Okay, so let's see this example. It is very important for you to analyze whenever you read any type of exercise if the events described are mutually exclusive or not, right? You should always analyze that before actually solving the problem. So pay attention at this one. It says, a box contains board pens of various colors. A teacher picks out a pen at random. The probability of drawing out a red pen is 1/5, and the probability of drawing out a green pen is 3/7, right? What is the probability of drawing neither a red nor a green pen? Okay, so in this case, if you realized, we're talking about a mutually exclusive, or we're talking about mutually exclusive events because the pen could either be red or green or any other color, right? But the pen cannot be red and green at the same time, right? That's why we're talking about mutually exclusive events. There's no way I can take out a pen which writes both in color red and color green at the same time, right? So let me write the information here. So the probability of a red pen is 1/5, and the probability of a green pen would be 3/7. So we're talking about mutually exclusive event because a pen drawn at random can only be in one color, right? One color, right? That's why we're talking about mutually exclusive events. So if we draw this, what is the probability of drawing neither a red nor a green pen? So if we kind of make a Venn diagram here, it's not 100% necessary, but just for you to be able to visualize what's happening. If we do a Venn diagram of the situation, we would say that we'd have red here, green here. Sorry, this is mutually exclusive. So as it is mutually exclusive, I'm gonna separate both circles, and I'm gonna put red in this one, green in this one. The probability of red is 1/5, so this is already the probability, and the probability of green is 3/7, right? So if I'm writing probabilities inside of my circles, then my universe should also be given as a probability, and the universe would be 100%, which is 1, right? When we talk about probabilities. So how much do I need to have outside of the two circles for the universe to be 100%, right? So all of the or the probability that we get outside of both circles would be the probability of drawing a pen which is neither red nor green, right? So I'm going to write this as x for now, and we're going to say that I know that the addition of all of the different probabilities should always be 1. So 1/5 plus 3/7 plus x should always be equal to 1, right? So if I solve this without using calculator, we can, I'm going to take all of the elements to the other side. So this would be x equals 1 minus 1/5 minus 3/7. And now I'm going to perform the common denominator, which in this case would be 35, right? Common denominator between 1, 5, and 7 is 35. So this would be 35 minus 35 divided by 5, that's 7. So minus 7 minus, and this is 5 times 3, 15. Okay, so this would give us, this is 35 minus 15, that's 20. 20 minus 7, that's 13. So 13 out of 35 is the probability of drawing a pen which is neither red nor green. So if we want to write this in a using mathematical notation, we would write it as the probability of picking let me see, it should be not red union, no, sorry, not union, not red and not green. There you go. That's what we're calculating. So the probability of the pen being not red and not green at the same time is 13/35. And this would be the result for this case. So you see that the way of solving the problem is exactly the same. You just need to realize that as we're talking about mutually exclusive event, there's no intersection between the elements. So basically what we're saying is that the probability of red and green at the same time is 0, right? That is mutually exclusive event. Let me write that here actually. Okay, so that's what we're saying there. Or maybe as it is data, I'm gonna put it here. Okay, so I hope this was clear enough for you juniors. This is it for today's video. Please let me know if you have any doubts about this. Next week, we're gonna be doing some exercises about all of the different concepts about Venn diagrams. And okay, just let me know if you have any doubts. See you.